looking at that idea of finding the slope of an instantaneous slope, so in this case it would be this purple tangent line here, that dotted line, we can find the slope by taking some secant line, so this green line, okay, so it shows the slope of the secant line over here. We can take that green line and we can take this point and bring it arbitrarily close to, we can bring it closer and closer to C. And as we do that, notice that the slope of the green line is approaching the purple line, and there it is. And from both sides, it's approaching the same point. So what we have here is h is the distance between C and that point. And as h gets arbitrarily small, okay, we get our h is our delta x, and our delta x is going to 0. So we're essentially dividing by 0. And as we get to that point, it disappears because we can't actually divide by 0. So slope of secant is gone, right? So if you just go back to there, so I'm just going to mist it again. If I just go right onto that point, there it is. The slope of the secant disappears because we're dividing by 0. But we can see as h gets really small, if we use a limit, we can see it's approaching about 1.2 something, right? 1.2, looks like about 1.2 from both sides. So the limit, as a two-side limit, as h goes to 0, it's approaching the same value, yeah. Although we can't evaluate that 0 over 0, we can use a limit to work that out. Okay, so there it is. So that's what we're going to do. We're going to find the slope at that point by just bringing that close, really close, and using a limit. And from either side, yeah, we're going to get that unknown slope right there. Oops. Just, yeah, it's hard to get. Anyways, there it is.